The word cryptography is derived from the Greek words crypto, meaning hidden, and graphene, which means to write. Cryptography is the enciphering of messages using a secret code. Cryptography has been around for many centuries, and some of the earliest uses of cryptography were recorded by the Romans and by Julius Caesar in a cipher known as the Caesar cipher, which was an early shift cipher, which simply shifted letters within the Greek alphabet a certain number of spaces to the right or the left to encipher a message. So if you had the letter phi, that might be shifted 3 places to the right and then be replaced with that corresponding letter. An algorithm is a mathematical calculation that's applied to data to form ciphertext or encrypted data. So the algorithm is applied to the data to encrypt it. And a key is a random bit of characters or a set of characters that are defined by a user that's used to encrypt or decrypt data. A password can be a key in many instances. So a key is a means of unlocking a bit of encryption. And a certificate is a digital document that includes information about the owner of the certificate. Oftentimes certificates are used to prove an identity, and they may contain information about an owner's public key. Symmetric algorithms are a type of algorithm that uses the same key on both ends. So to encrypt and decrypt data, the same key needs to be used. So if you want to send encrypted data using symmetric encryption, you would encrypt the data using one key, send the data, and then the recipient would decrypt the data using that same key. This could be a password. So you would apply a password to encrypt the data, send the data in an encrypted form, and then the recipient would decrypt it using that password as well. Symmetric key encryption is often referred to as session key encryption because a session key is a symmetric key. So think of symmetric key encryption kind of like a house key. Anybody with access to that house key has the ability to unlock the house. And you can make duplicates of that house key and distribute them as the house owner as you see fit. Some examples of symmetric key encryption include Blowfish, the Advanced Encryption Standard, the Data Encryption Standard, and the Triple Data Encryption Standard. DES and 3DS were supplemented or supplanted by AES. They were replaced by AES later on. And Reverse Cipher 4 also uses symmetric key encryption. Blowfish is a very good symmetric key encryption that's often used with Unix and Linux devices because it's been made open source. I'd say it's comparable to AES. AES is the standard used with U.S. federal government agencies. They require AES and it can support key sizes of 128 and 256 bit. Asymmetric algorithms are algorithms that work with a public and private key. So one key is used by the person who wants to encrypt the data, and then another key known as a public key used by anybody else who wants to decrypt that data. What this does is this protects data integrity because it shows that the data was encrypted by a single person, the owner of the private key, because it can be decrypted with that public key. So that public key can only decrypt data that's encrypted with that private key. It can't be used to decrypt any other type of data. So if you can decrypt the data with the public key, you know that it was encrypted using that private key, and you can ensure that the person or the owner of the private key encrypted the data. The same thing can be true in the reverse. If you want to send a document and you want to make sure that only that one recipient can decrypt the data, you can encrypt the data using that recipient's public key. Then the only person who can decrypt the data would be that recipient, the owner of the private key. Asymmetric encryption is used with digital signatures, and oftentimes a digital signature is included, or a private key is included private key is used to encrypt a package that includes a public key and a digital signature. And we'll talk about that when we talk about digital signatures later in the course. Some examples of encryption algorithms that use asymmetric keys include Reves-Shamir-Adleman, or RSA, Diffie-Hellman, elliptic curve cryptography, or ECC, and El-Gamal. Diffie-Hellman can actually use this asymmetric algorithm to create a session key, create a symmetric algorithm, and we'll talk about that later in the course as well. And then public key infrastructure allows for the use of asymmetric encryption algorithms. We'll talk about public key infrastructure again later in the course. A hash is a cryptographic function. It's a string of characters that's created by applying a cryptographic function to a string of data, known as a hashing algorithm or a hash function. So you would apply this hash function to a bit of data, and that data can be a variable length, and then you'll receive from that a fixed length hash. And what this does is this will give you a manageable string of characters that can be used to verify data integrity. And if you apply a hash to data and then send the data or transmit the data, the recipient can apply the same hashing function to that data, and then the two hashes can be compared, the hash from before transmission and the hash after transmission. If they're the same, then data integrity was maintained throughout that transmission. This can also be used to ensure data integrity when data is stored in storage. The data integrity can be checked as the data is being recalled and the hashes can be compared from when the data was stored, the data was stored, to the data was recalled. If they're the same, then there's been no data degradation. Hashes are incredibly important also for protecting passwords. When a user inputs a password, oftentimes instead of using that password directly, a system or authentication system will take that string of characters that the user inputted and run a hashing function on it. Then they'll compare the hash with the hash that they have stored, the authentication server has stored within its database, and if there's a match, then the user is authenticated. In this way, the authentication server does not need to store passwords directly. So if attackers were to hack into the system and gather a list of passwords, they would only find a list of password hashes. They wouldn't know what to actually type in to the authentication page. This is incredibly handy and makes it so that if attackers recover that data, they don't have the means to go and compromise accounts right away. Secure hashing algorithm 2, or SHA-2, is often used in this regard. There's also hash-based message authentication code, or HMAC, and message digest 5, which is a very simple but very useful hashing function. It has security vulnerabilities and shouldn't be used for password hashes, but it's very good for verifying file integrity pretty quickly.